Hello again, Calculus. This is the last of our trig rules notes for 2A. Last of our derivative rules, all trig derivatives. So we've done a few of these already. Let's get the others and see how they work inside all of our other rules with products and quotients and chain rules and everything else. We've done some of these before. Two questions to answer as you go through this one for the points. Make sure you get those. All right. Some that we've done before. First three here, you should know. All of these we do need to have memorized. So forwards and backwards, you got to know these. So memorize all these trig derivatives. Okay. You already know the first ones. The derivative of sine, for example, is. That's right. We know that it's cosine x. Cosine was negative sine x. All the cofunctions, if you remember from last year, are negative. So cosine and negative sine. Now, we went through the quotient rule for tangent in a previous lesson. So we just got that one came out to be secant squared x. So tangent turns into secant squared when you do its derivative. And cotangent, there's a relationship with all these cofunctions. So cos will be negative, and the cofunction is related to secant. It's its cofunction, cosecant squared x. So we have cosine to negative sine. Over here, we have secant squared to negative cosecant squared. We could do a cosine over sine quotient rule, but we're not going to go through all that. Cosecant and secant. Again, cosecant, we could do 1 over sine and go through a quotient rule or an exponent with a negative 1 on it. But instead, we should just remember these. I don't know why I switched these around. Secant is usually first. Let's do secant first. Secant, remember these two turned into two trig functions. This one was secant x times tangent x. And cosecant, so its cofunction must be negative, and the cofunctions of secant and tangent are cosecant x, cotangent x. Now the cosecant and secant, they do turn into two trig functions, so we have to remember that as we get some chain rules on there and things like that. All right, so keep this handy and always refer back to it until you know these forwards and backwards. You have to know your trig derivatives. You don't want to spend time doing a quotient rule or anything else to get tangent or cotangent or anything like that. So make sure you know these 6. We knew 3 before. Now we have the 3 others. All right, let's use these. When we use trig derivatives, we always want things to be as simple as possible. So remember your identities. These are the ones you should know, besides the easy quotients of tangent of sine over cosine and secant is 1 over cosine, things like that. Pythagorean identities, we should know all 3 of these. So sine squared plus cosine squared equals 1, and be able to mix it around. Tangent squared plus 1 is secant squared, and cotangent squared plus 1 is cosecant squared. Double angle formulas. Most of the time when we use these, we're going to go kind of backwards like this. We're going to take 2 trig functions and make it into 1 to make things simpler. Same thing with the cosine of 2x, cosine squared x minus sine squared x. So a lot of times we're going to see if we can make problems simpler by going backwards here. So those are the ones we need to use to make problems simpler. Basically, if it looks pretty complicated to do the derivative, there's probably trig identities that can make the whole problem easier. That's what we want to remember. So let's find some derivatives. Some we have seen before, others we're going to use simplifying and other kind of rules to do here. But you have all your 6 trig derivatives. They just fit into the other derivatives pretty easily. All right, we've seen one like this before. So cosine squared 3x. We have to remember the order on this kind of problem. There are 3 things happening on this. There is, to rewrite this, an exponent. Everything is being squared. Okay. There is a trig function. So there is a cosine in this one. And inside the trig function is our angle, 3x. So remember the order that you do the derivatives is exponent first, then trig function, then angle. This is a three-layer chain rule. This is two links in the chain. We're doing two chains with this. All right, let's do it in order. Remember, what I wrote here is just an explanation of where that exponent is. It's not the derivative. Label your derivative every time. So here's where we're starting with the derivative. dy dx is, first layer is the exponent 2, and the first. I'm just going to label that so we remember it. You don't always have to label a first power. Inside stays the same, cosine of and the 3x. The next layer, our chain rule multiplies by the derivative of the next layer, and that is cosine. Derivative of cosine is negative sine, keep whatever's inside, 3x. We haven't touched the 3x yet, so that's our second link in this chain. So the next layer, we just have to multiply next to it, and that derivative is 3. There's a little expanded version of this. We're going to clean it up a little bit, but that was two chain rules in there. So 3 layers, 2 links through our chain. Now to clean this up, we do want proper notation with exponents. We want to gather all factors together. So this one is going to be 2 times 3, and don't forget the -1 in here. Multiply by -1 next to the sign. So that makes -6, and we have a cosine 3x and a sine 3x, all multiplied together. So we've got it simplified down here. There is more we can do, but that is our 2 steps through 3 layers in the chain rule. All right, to simplify this, we would like to have as few trig functions as possible, whether we're starting a derivative or finishing it. And this one we're finishing. We have 2 trig functions, but we can simplify this down. So we have, the key here is we have a sine multiplied by a cosine with no exponents on it. That should remind you of a double angle formula. So a double angle formula, that has sine and cosine multiplied. Sine of 2x is 2 sine x times cosine x. Well, that means if you see a sine times a cosine, you can go backwards and make it sine of 2x, as long as you take a coefficient of 2 with it. So I'm going to rewrite this here so we see it more clearly. I'm going to split up the -6 into -3 times, I would like to have a 2 in my formula. So -3 times 2 is 6. Cosine times sine is the same as sine times cosine. So sine 3x, cosine 3x. This is our double angle formula. So whenever you see a sine times a cosine, no exponents allowed, you can take that and factor it down or simplify it down using our double angle formula. We end up with -3 times, and all this is sine of double the angle. We had 3x, double it is 6x. And that is the simplified derivative. We would like to have as few trig functions as possible in our answer. Okay? Let's see the next one here. X times sine x. Now, we have to recognize what rules to use. Always look for where your variables are. This one has an x variable multiplied by. So the variable multiplied by some more variables. Sine of x has a variable. So this isn't real complicated. It's just 2 parts multiplied together, 2 functions multiplied together. And that means we are going to use a product rule. Okay. X is our first function. Sine of x is our second function on this. So we should be able to step right into the product rule here and say derivative of the first one. Derivative of x is 1, original sine x, plus original x times the derivative of sine x, which is cosine x. So that is pretty much our answer. You don't need to write 1 times sine x. You could just have sine x plus x cosine x. But trig functions just fit into product rules pretty easily. Okay. Number 3. There are a couple ways to do this one, but on each of these, the directions have said try to simplify first, especially if it looks more complicated. Well, if we didn't simplify this, what I see is a multiplication problem between sine and cosine. So I would have to do a product rule. Inside the sine and cosine, each one has their own angle, so we'd have to do a chain rule with that angle. There's an inside layer. Instead of that, We should recognize this. We have a sine times a cosine, no exponents. We've got a 2 in front. This is our double angle formula. It's always easier to do derivatives with fewer trig functions. So if you can simplify it down, do that. 2 times sine times cosine is sine of double the angle. 3x, double it is 6x. That's not a derivative. That's still y. I kept my equals going. So now we can do the derivative. dy dx, much easier than using a product rule right now. This does have a little chain rule in it. No exponents, so we go right to the trig function. Sine gives us cosine. There we go, cosine of 6x, and our chain rule is times 6. So the best way to write that is 6 times the cosine of 6x. Much easier than doing a product rule with 2 chain rules inside of it and then trying to simplify that down. You'd eventually get the same thing, but it'd take a while. So simplify first to make derivatives easier to do. Know those double angle formulas. All right, number 4, this one should be obvious. You want to simplify. I definitely don't want to do a quotient rule, we have division, with 3 different trig functions in it. That would be a lot of writing down and then a lot of simplifying. So try to simplify on this one first. Let's see what we got. What I noticed on top is we do have these functions that are squared. So when they're squared, I want to think of Pythagorean identities. And if you just look back, we have a Pythagorean identity that says tangent squared plus 1 equals secant squared. That has a tangent squared and a secant squared. Let's rearrange that one. And tangent squared, if you subtract secant squared, you have to move the 1 over, so it equals -1. All of that on top we can make much easier, is -1 over cosecant x. That is much simpler. But it's not as simple as it gets. We can even do more. Remember, cosecant is a reciprocal. 1 over is a reciprocal. Well, the reciprocal of cosecant, that's just sine. So this is 1 over sine. That makes sine of x. We do still have to keep this negative there, so negative sine x. That is not a derivative. That just simplifies it down. So I kept my chain going here of equal signs from y. This is y equals. So now we can go back and do our derivative finally. So from negative sine x, much easier than it started with. dy dx is sine x is just cosine x. Remember, any coefficient just goes along for the ride, so that negative is still there. Negative cosine x. So simplifying makes these problems easier. Know those Pythagorean and double angle formulas to help you simplify. All right, number 5. Write the equation for a tangent line to this. Anytime we write the equation, we should know what to do. We can put trig functions in all of these type of problems. Find the slope, write the equation, find where it's horizontal, tangent line. So we know what to do with this. Anytime you see write the equation for the line, you know you need 2 things. What 2 things do you need to write the equation of a line? All right, we know what we need. We need a point and a slope. Remember, a point comes from the original equation. We have pi for the x value. We need to find the y value, so we plug that in. The y is pi times sine of pi. Just use the original equation. That's pi times sine of pi. Do a quick little unit circle over there. That sign is 0. Pi times 0 is 0. There is our point. Original equation, plug in, know your unit circle with these. The slope. Slope, we know we need a derivative, so we need a dy dx. This is x times sine x, variable multiplied by more variables. That is a product rule. And luckily for us, you guys already did this one. Look back at number 2. Number 2 said the answer was sine x plus x cosine x. You can do it again if you want to, but that was our product rule, what it came out to be. So let's plug in pi. Sine of pi plus pi times cosine of pi. That x in front, just plug in the pi in there, and it's a number now, a coefficient. Well, sine of pi is 0, plus pi times cosine of pi, the x value over there is -1. Well, that all ends up being negative pi. That's okay for an answer. That's a number. The slope is negative pi. So point and slope, we can put it into the form y minus the y value 0 equals slope negative pi times x minus the x value, which is pi. That is good for your answer. You don't have to write -0. You can just say y equals negative pi times x minus pi. That works too. All right, so equations of lines, same, just use your unit circle to plug in. And last one, use your calculator to find this. This function that you're given, x to the power of sine x, we haven't done anything with variables inside the power, so that's for chapter 5 later. So x sine x, what can our calculator do? Well, I've got some screens here for us to walk through. Remember, we did some of this last year. What your calculator can do is find a derivative and plug in a value to get you the answer. It will find the slope of this weird graph at pi over 3. It won't tell you how it did it. It won't find the derivative equation, but you can have it do the answer for the slope. So what you need to do over here on your calculator, if you remember where this is math class. So we're going to use the math button right there. So if you press math, you get this screen, and we're going to do the numeric derivative. Find the number for the derivative, and that is number 8. So do math, number 8, n deriv, and that should show you this screen. This is the notation we've been using. So the pieces that you need for this notation, you kind of need to fill in the blanks. The first little fraction here means take the derivative of dd something, and that's a variable. So this one, you just need to type in the variable, and that one is, in our equation, that one is x. So type in the x there. Next, that'll automatically put an x right there for you. Next, we need the function, the equation right there. You don't need to put f of x equals, just type in the equation, x raised to the power of sine x. We're using trig, so make sure you are in radians up here. And the last thing, this is now x, and it says equals. Remember, this bar means evaluated at. That is where we put the value to plug in. So this is going to be our pi over 3. It should look like this next screen down here, ddx of x sine x, where an x is pi over 3. Just hit enter, and it gives you the value. Always leave at least 3 decimal places in your answer. So 0.884 is the slope of that, whatever graph looks like, at pi over 3. But that is the derivative with pi over 3 plugged in. That's what your calculator can do. So make sure you know how to use that. We won't use the calculator most of the time, but when you can, and it asks you to find a slope, you can do that on the calculator. All right, that's it for 2.8, and the last kind of notes in the first half of chapter 2, the 2a chapter, all the rules for derivatives. You know, power, product, quotient, chain, and all the trig rules here and how to mix those together. All right, that is it for the notes for these remote days. You've got 2.8 with this one with trig functions, and 2.9 and 2.10 are both reviews of all kinds of trig rules, all mixed together for you. All right, make sure you try those so you can ask questions next week after the SAT test. I'll see you then. Bye.